Okay. So today's session, we are going to deal the main topics in 2 days. I'm going to take today and tomorrow. So it is the main topic is vision and objectives of applied mathematics. So on 12th today, we are going to learn what is the vision and also what is the objective. And along with that, one topic I have taken, that is numbers, quantification and numerical applications. And this is actually class 11 one topic and class 12 one topic I have taken. And tomorrow it will be it will be taught financial mathematics and logical reasoning. So in this numbers and quantification, it's a very big unit. A few concepts only I have taken, and the full complete unit I'll just show you that what are the topics are there, and all the details I'll be just telling you. I think this is actually why this applied mathematics, mainly for the commerce students. This question every year the student will have in their mind. So after my class 12, I'm going to do some BCom, BBA, or some kind of commercial mathematics like business mathematics, or it is CA, mass communication, law, or competitive exams like IAS, IPS. Those aspirants only mainly will go for the commerce stream. But their question is why I have to do trigonometry and 3D vector, these things. So this is taken in the mind, and CBSE has designed the curriculum, which is the applied mathematics. So these ideas here, it is given by the CBSE, that points only I have taken here. So it is, we know that mathematical skills are needed in every field, actually in the field of art or literature or social science, everywhere in our daily life, personal lives also, we are using the mathematical skills. So these mathematical skills, how we are going to apply it and what is the use later, that is the purpose behind this course. And this is senior secondary school education. This is given by the CBSE. In the, I have highlighted with the red color, you can see that here. It has been observed that the existing syllabus of mathematics aligns well with science subjects. So what we are teaching in 11th and 12th mathematics is mainly focusing only in the science subjects. So it is not focusing for the commerce students or social science based subjects. So for the higher studies, those who are aiming for them, they need a separate curriculum. For that only they have designed this applied mathematics, and it provides the relevant subjects or topics, whichever they need it for their future. That is given meticulously, I have to tell that. So they have done it very carefully, the topics were chosen. And this is actually the course name previously, applied mathematics, the same name they were using for the skill subject. So it was a skill subject till 2019-20 batch. It was considered applied mathematics as a skill subject. The code number was 840. And CBSE has introduced this new academic, this is an elective subject equivalent to mathematics. And it is secondary level name. This is applied mathematics. Here the code number is 241. So mathematics 041. Here applied mathematics is 241. And here, but both are elective subjects, equivalent valid, equivalent weightage, everything, difficulty level, everything is same. And starting from the academic year 2020-21 for the classes 11, and the first batch already they have entered into the term 1 examination, board examination. So this is the class 12 syllabus alone I have taken. And here we don't have any NCERT textbook as we have in the science, I mean mathematics. So we cannot say science mathematics. We have to say that code number 041 mathematics. So that is just called mathematics. This is applied mathematics. So mathematics syllabus, when we compare here, actually, this course, we have a textbook there and support material separately. But here only student support material alone is introduced by CBSE. We have to, based on that topic, we have to go extra reference books, and we have to give separate notes from that. So that is not sufficient. They themselves mentioned in the support material that don't depend only on this. We have to take extra and prepare the students for the board examination. So this is class 12 syllabus. Quantification and numerical applications. This is the unit 1. So unit wise only I have taken. So unit 2 is algebra. Unit 3 is calculus. Unit 4 is probability. Unit 5, inferential statistics. Unit 6, index numbers. And 7, financial mathematics. And 8 is linear programming. So in this, some topics are common. So that comparison, I will just tell you that. So this quantification and numerical applications really very useful for the students, those who are going for the competitive examinations. So any examinations for CA Foundation, or it is a TNPSC exam, or it is for the Staff Selection Commission, or your UPSC examination, anything you need this basic concept that fully they cover. In 11th standard, they cover the logical reasoning, all kind of blood relation topics, like whichever you need it for your, actually our school, we are doing the Pragya exam, the same pattern, you have all the questionnaire in the 11th standard. Algebra covers matrices and determinants, and also a few statement problems. Calculus, we have everything other than trigonometry and inverse trigonometry. So calculus, you have all 5 topics, like differentiation, application of derivatives, and integration, applications of integration, differential equations, everything is there, but no trigonometrical concepts. And probability, we have in class 12 only, it is up to, we have a binomial distribution, that also deleted, but they have, they learned in class 11 itself up to Bayes theorem. In class 12, they learned binomial distribution, Poisson distribution, normal distribution. So many extra they are learning this commerce streams. The inferential statistics is totally different from the descriptive statistics, which we learn in class 11. Mathematics, that is different. And here it is inferential statistics, is deriving the result from the statistical analysis. And it is one of the interesting topic. It is little, actually they have to think a lot concept wise. Different tests they will be using, and finally conclude what is the result. That is result oriented inferential statistics. And index numbers and time analysis, there is another topic. In this topic, 6th one, everyone will score full mark, easy topic. Financial mathematics, another one. Here it covers all GST, and also it is covering a EMI, loans, and sinking funds. How business, when you are starting a business, what kind of knowledge you need it. So how to purchase the stock, or you are buying the debentures, or in which way you can deposit your money, or you can, which share, if you buy it, it is going to be useful, the profit will be more. All kind of calculation and ideas you will get it when you learn this financial mathematics. Of course, it is also covering like the topic, it is mainly like a calculation in the our income tax calculation. Our own income also we can calculate and find out how much we'll be getting, all that. So linear programming is exactly same. The next one is, here it is how this application, that is applications of this applied mathematics, it is useful in the competitive examinations. So I think everyone knows that. So here the how the subjects to be chosen. In class 9, we just call mathematics. In class 10, it is standard mathematics, basic mathematics. So here you have a doubt, like whether standard mathematics, those who have taken, whether they can take applied mathematics. It is possible. Standard mathematics, you can go to mathematics or applied mathematics. Similarly, basic mathematics, those who have taken, they can take applied mathematics. Even in our school, we have one student who studied in class 10 basic mathematics, attending now. She is taken applied mathematics. So next we have this class 11 and 12, when you take mathematics, applied mathematics, then what are the courses they can opt later? It is only mathematics, those who are chosen, they can go for engineering, BSc, and mathematics honors related to that, anything they can take. But if you are taking applied mathematics, those students cannot go for the engineering, though they are taking. So it is available. They can go physics, chemistry, and biology along with applied mathematics, but such students, they cannot opt engineering courses or BSc mathematics. So this applied mathematics, they can go only with it. It's mainly you can go for the commerce stream only, it is useful. So they can take BCom, CA, arts, competitive exams in that way. So this is the comparison between class 12 syllabus. Already I said this one. So the first topic is, well, this is the first unit. This covers all the topics, whichever is given, is very, very useful for the student, those who are attending the competitive examinations. I'll show this first topic only today. I'm planned to show it. So in this, you can understand that how much we are using. So many of us would have attended the examinations like the Staff Selection Commission or TNPSC. We come to know that all kinds of questions are here. And algebra, you have matrices, determinants, same topic. So I have highlighted the red color, which is same topic, but along with that, they learn Cramer's rule, Leontief, and input-output model. Extra they learn here in the matrices. And differentiation and applications. Here, how nicely they will relate the topic with the demand and supply curve. So demand and supply curve topics only, though they are learning differentiation and integration, the questionnaires will be related with their own topic, economics, like demand curve, supply curve, like how we are using the function, different functions. Based on that, they will be finding the integration, all kinds of methods of integration they will introduce in doing the demand curve and supply curve. So similarly, differential equations, all statement problem here fully. So case study question, this year they have introduced from this modeling only. And probability, already I said that additionally they are learning Poisson and normal distribution. Inferential statistics is one among that topic, which is different, totally different topics. And index numbers and time-based data is the easiest topic. Financial mathematics, if you know the formula concept, that is one of the easiest one. And linear programming. So test, what is the internal assessment? The internal assessment for mathematics, actually, everybody knows it is test and activities, record work. But here, practical and project work only. So 10 marks for practical, 10 marks for project work. So this is practical also, they are introduced in the book itself, in the supplementary, that is support material. They have introduced what are the practicals they can do it. In the computer, they are doing, they are bringing the demand curve and supply curve picture using the given data. It's very nice new experience. Really, it was a very good experience. So this is the first topic. So in this topic, you can see that what are the kinds of, it's why main unit is numbers, quantification, and numerical applications. We have so many subdivisions in this. So the first part is number theory, modulo arithmetic, simple arithmetic, congruence modulo. So this is the one of the simplest one only. So first one is pipes and cisterns. These problems and all, you would have noted this in class 8, 9, and 10 mostly. We would have taught few concepts, which are the concept like pipes and cisterns, like two pipes they opened at the same time to fill the tank, such questions. And the next, boats and streams, in class 10 also we have the same concept only. So additionally, we have a few concepts, that is allegation and mixture, partnership, races and games. So these three are additionally, and scheduling. So scheduling is this time deleted concept. So these three we have as it. Allegation and mixture, partnership, races, and games. In class 11, the same topic, we have calendar. So I just took one topic from calendar, how we are calculating, another one here, allegation and mixture. So I think this is the basic introduction about mathematics. So the questionnaire, what I gave, now you will be come to know the answers, I hope. What is the answer? Actually, it is an elective subject, difficulty level same, and also what are the questions you made it wrong. I hope you would have got the correct answer now. So now we'll go to the first topic. It is allegation and mixture. So here it is two items, two ingredients, they mix together and they produce a new mixture in such a way they want to produce the cost amount, the desired amount. So to bring that, what ratio they must mix the two, it can be a liquid or it can be any items. The two items, when we mix together, we want to produce a desired cost. So what is the way, what is the ratio in which we have to mix? That is the allegation and mixture. So the definition here is mixing two or more ingredients together in certain ratio is known as a mixture. And what is allegation? Allegation is a rule, just it is a rule assigned in which two or more, so ratio in which two or more ingredients are mixed together to give an price to produce a mixture of desired price. So here we have only one formula, like a formula, this one part only. Using this, you can create so many questions. So in the textbook, they have introduced in the support material only two questions, but if you see in the other extra reference books, you have a plenty of questions related to this. So all that the students, they must be knowing that how to do. They must learn all these methods. So here, but basic concept is one formula only. So what is the rule here is, before that you should know what is the meaning of mean price. Mean price is like it is the cost price, the cost price of unit quantity of the mixture. What is the meaning is, we have to divide the two items. One is a dearer price, another one is a cheaper price. So anything, sometimes you are mixing water and the milk. So milk will be costlier. So the which ingredient is costlier, we call it as a dearer. So dearer means it is an expensive one. So the cost of the dearer amount, and another one cheaper amount. So cheaper ingredient, it can be a water or anything. So it is a mean price of a mixture is denoted as M, and cost price of the cheaper ingredient, we are using the letter C. So whether I can use. So just this formula alone, we can learn one formula. It is, what is the letter we are using is the dearer price, means we are using D letter. The cost price of the dearer ingredient is D, and the cost price of cheaper ingredient is C, and the mean price of a mixture is M. So these three letters we are going to use, and this is the formula. Quantity of a cheaper ingredient upon quantity of dearer ingredient is equal to CP of dearer minus mean price upon mean price minus CP of cheaper. So this easily, with the, instead of by hearting in that way, this is easier way. It is introduced in the book itself that you have to take a cheaper ingredient, that cost price, and here dearer ingredient cost price, and this is C and D. Just you have to subtract. Mean price is here. So when you add both, what is the required one? This is a mean price here, and subtract D minus M, and this is M minus C. So the formula ratio of cheaper and dearer is equal to D minus M is to M minus C. This first formula, this is the second formula. So suppose sometimes when we are using the liquid, we want to make it still more thinner, we'll be removing the liquid, what it has already, we'll be removing, and we'll be adding water additionally to make it thinner. So this is number of times. So here another formula, suppose a container contains X unit of a liquid from which Y unit are taken out and replaced by water. If we repeat the same operation N times, then the quantity of pure liquid is given by X times 1 minus Y by X, the whole power N unit. This is the formula. So we have only two formula. So first formula, ratio of cheaper and dearer, which is D minus M is to M minus C. The second formula, totally you have X quantity, in that you are removing Y quantity, Y unit of a liquid out. How many times you are removing and adding water, that number of times we use it as N. So based on these two formula, we are going to see the sums. So the first question, this is a direct question. In this, you can see, in what ratio must a shopkeeper mix two types of oranges worth rupees 560 per kg and rupees 90 per kg respectively, so as to mix a mixture? In what ratio must a shopkeeper mix two types of oranges worth rupees 60 per kg, 90 per kg? So we have to take 90 rupees as a cheaper ingredient, and rupees 90, that is a cost price of the dearer ingredient, and the mean price is rupees 80. So this is one of the direct question. So we can write the answer. Cost price of, I write just formula. First we have a CP of cost price of dearer ingredient. equal to rupees 90 per kg. And CP of next one is cheaper ingredient. Cheaper ingredient rupees 60 per kg. And cost price of mean, actually mean price. So it is, I have to write mean price equal to rupees 80. So a formula. So I think everybody remembers now the formula. This is quantity of cheaper ingredient divided by quantity of dearer ingredient equal to formula D minus M divided by M minus C. So D is dearer amount. Here it is dearer amount. This is D and this is C and this is M. So apply it in the formula. D is now 90 and M is mean price 80 and M it is 80 and C which is 60. So it is 10 upon 20 which is 1/2. So the ratio in which they have to mix is 1:2. So the ratio is 1:2. So this answer actually direct question, we can do it. Now I'll show you little higher order here. So this is the question actually given in the sample paper, and they asked from this topic also there was a question. So here a retailer has 250 kilogram of rice, a part of which he sells at 10% profit, and the remaining quantity of rice is of low quality, and he sold it at 5% loss. Overall, he made a profit of 7%. Find the quantity of rice sold at 5% loss. So this question actually, you have to apply the same concept, which is dearer cost and the cheaper cost. First, we have to identify. So here it is a profit. So the profit which we taken as a dearer. So D is 10%. And here he is selling it at a loss of 5%. So loss of 5%, we consider that is a cheaper cost. So a cheaper ingredient, so that will be taken as minus 5%. The reason is it's a loss. So loss, so it is minus 5%, and D is profit, which is 10%. And the mean price, you can see that overall he made a profit of 7%. So total profit, what he received 7%, that is the mean price here. So we know the formula D minus M and M minus C is required. So the ratio we are calculating using the formula D minus M divided by M minus C. So it is subtracted here. D minus M is 10 minus 7. You have here 3. And C, M minus C, you get the answer. It is 12. And it is 7. Sorry, 7 minus of minus plus. So it is 12. So 12%. So we'll reuse the same formula D minus M by M minus C here. So
1:4.
So we get actually 1:4, you got it. See, this 1:4 ratio is only for the least quantity, that is a loss. So loss is 1 part and profit is 5. So total, sorry, profit is 4. So 5. In that, the question is actually, there is a question, we want to know that find the quantity of the rice sold at 5% loss. So 5% loss, we got it. It is, he is selling it 1 part out of this 250 kilogram for the loss and 4 part out of this profit. So the question is, we want the quantity of the rice at the loss. So it is only 1 part. So 1 out of 5 of this 250 kilogram. So you get the answer, 50 kg is the answer. So this alligation mixture, this related with this concept. Next, we have now you learned one more formula, that is x times 1 minus y by x the whole power n unit. This is the milk contained by the container. When we are removing white amount of quantity from the available x unit, and number of times we denote it as n here. So the question is, container contains 40 liter milk. From this container, 4-liter milk was taken out and replaced with water. This process was repeated further 2 more times. How much milk is there in the container now? So the total milk in the container is 40 liter, and taken out how many liters of milk? It is 4, and number of times the process happened is 3 times. So we use the formula directly, and this is one of the direct question. So we are substituting the quantity X is 40 and 1 minus Y is now how many liters we have taken out? 4, and X again it is 40, and whole power N is 3. So simplifying, you get the answer 29.16 liters. So this is you have a nearly some 10 model questions are they based on this alligation and mixture. And the next one is a very simple concept. I am not going to explain much because everybody knows this concept very well, pipes and cisterns. So as we know that 2 pipes open at the same time, and one pipe will be leaking out the water, then how much time it will take, or sometimes all the 3 pipes will be opened and 2 pipes will be stopped after some time, and what will be the time taken to fill the tank. Such questions we have here. So all these questions you can understand that this is useful in the competitive exams only. So here everybody knows I'm just showing the question only here. So 2 pipes can fill a cistern in 8 and 12 hours respectively. The pipes are opened simultaneously and it takes 12 minutes more to fill the cistern due to leakage. If the cistern is full, what will be the time taken by the leakage to empty it? So here there are 2 pipes are opened at the same time. So we calculate it for 1 hour how much. We know that this concept and all in 8th standard, 9th standard mainly they have studied. Even 10th standard this concept comes. So it is filled by the portion of the cistern filled by both pipes in 1 hour. Reciprocally we'll take it 1/8 plus 1/12, which is 5/24. Therefore time taken by both pipes to fill the tank will be 24/5 hours. So this you have calculated. And now what happens because of the leakage, they are taking additionally 12 minutes. So the 12 minutes is added here, 4 hours, 48 minutes plus 12. And so it is 5 hours. Now all the 3, when they are actually not 3, 2 pipes, and all of a sudden leakage also to be counted. So 1/5, it takes how much time it takes here? It is already we have calculated 5 hours means in work done by the pipes and leakage in 1 hour is 1/5. So the work done by leakage is totally it is 5/24 work done is done. In the due to leakage means negative sign. So minus 1/5, we are getting 1/120. So the time taken by leakage to empty the tank is 120 hours. So this type of questions, you know it, so I'm not going to explain much. And first one, alligation and mixture, I think it is a new concept for everyone. And pipes and cisterns are same, simple only. Partnership also, here they are learning different types of partnership questions are there. This also simple only. Students answer very well this type of questions. So what is the meaning of a business partnership? The introduction, a specific kind of legal relationship. We call it as a business partnership. And here they are doing, because they are due to agreement between the 2 people, they are making themselves as a business partners. And using this partnership problem, I have taken one simple question only. 3 friends A, B, and C enter into a partnership to run a cafe business. A puts in rupees 5,000 per month for the whole year. B contributes rupees 3,000 per month at first and increases his contribution to rupees 4,500 at the end of 4 months, while C puts in at first rupees 4,000 per month and withdraws rupees 1,000 at the end of 9 months. How should they divide a profit of rupees 10,200 at the end of the year? So it is contribution. They want to know that how much profit to be contributed to each one. So first it says that A is depositing 5,000 rupees per month for the whole year. So it is 5,000 into 12. So the deposit amount by A is rupees 60,000. and B contributes rupees 3,000 per month at first and increases his contribution to 4,500 at the end of 4 months, which means he is only 3,000 rupees depositing in the beginning, first 4 months. So first 4 months, his contribution is only 3,000 into 4. So you can see that 3,000 into 4 and added with the remaining 8 months, he is spending rupees 4,500. So the total amount he deposited will be for the throughout the year is rupees 48,000. Same way for C, you can see in the statement, it is given in the statement. Well, C puts in first 4,000 per month and withdraws rupees 1,000 at the end of 9 months. That means 4 months alone, he is depositing 4,000. And later he is taken 1,000 rupees, he is reducing it. So he has to take now, it is how many months? 4,000 per month, withdraws 1,000 at the end of 9 months. So 3,000 rupees, he is depositing 9 months, 4,000 rupees. And for the remaining 3 months, it is only 3,000. So based on this total, with this concept, everyone knows the total, we have to see that ratio 60,000 divided by the total amount into the A's share, B's and C, we calculate it. And another one, boards and streams, very familiar question. This is upstream, downstream concepts, which we learn in class 10 also and 9th also they have introduced. Same concept we can use with the U plus V, U minus V concept. We can explain to the students, same type of questions only here. But there are many higher order questions apart from the class 10 questions. We have many extra also, but everything they are given in the APC book, all easy, tricky way how to calculate the answer, it is there. So next important concept is calendar. So in the calendar, you think why I have taken this topic? It is very interesting. It is totally different from what we have learned. It is what was the day on 29th November 1972. So we want to know that what is the day. It's a decoding a particular date. We are going to find out what was the day on the particular date. So 29th November 1972. Can anyone say that is it possible to say directly? Only if you have a Google or something, a calendar, we will see and tell. But there is a calculation. This is one of the important question also in the applied mathematics. So I'll teach you today this calendar, how to calculate this. This will be definitely interesting. So calendar concepts, it is depending on odd days and how many odd days are left. So what is the meaning of an odd day? Odd day is nothing. I just show you. See in the structure of the calendar. You have an ordinary year and leap year. In the ordinary year, we have 365 days, 52 weeks and 1 day. So the 1 day which is left out, we call it as an odd day. Similarly, in the leap year, 366 days. In this, 52 weeks and 2 days remaining. So here you can see the pipes and cisterns questions. I explained this part only. The 2 pipes can fill the cistern in 8 and 12 hours. This question I explained actually. I think it is simple.
Even without seeing that screen, we are able to grasp your this one. Yeah, very clearly we're explaining. But even though it is not showing that screen, I'm able to grasp. Yeah.
Actually, I was thinking I am sharing it.
Yeah, that's one. Okay.
Okay, this question answer also is there here. I have done the answer also here. So the portion of cistern, this is 2 pipes questions and partnership question. Also, it is given here. So should I do it again or you can understand?
No, it's fine.
So calendar, shall I start now? I'll come back to this if I have time.
Yes.
So the boards and streams, this question only
Yeah,
I already told upstream, downstream, you can do it.
Yeah.
So this here there are many higher order questions. So this is the calendar question. What was the day on 29th November 1972? So this only I asked the question, can you guess it? What is the day? It is not possible. So this calculation only I'm going to teach mainly this topic. So in this calendar, we have this is the structure of the calendar, ordinary year and leap year. In the ordinary year, number of days is 365 and number of weeks. So number of weeks, we have to divide by 7 and how many days left out, we call it as an odd day. So in the leap year, 366 days, 52 weeks and 2 days left, that is called as a odd day. So the extra day left after exact number of weeks is considered as an odd day. So what is the meaning of an odd day only? We should know based on that only the questions. Now we have to calculate the odd days for the months. So January month, if you see that there are 31 days. In the 31 days, you divide by 7. So 4 complete weeks and 3 odd days you will get. So it is 3 here. Similarly, every month we have to divide by 7 and the number of days left out, we call it as a odd day. Now, based on this odd day, I have to introduce this one. I just, can you see now empty page I'm showing? Can you see that?
That monthly odd days, month-wise odd days. February 0 or 1, madam?
That only is shown, sir.
February month, 0 or 1 is odd day.
0 or 1 means it is leap year or it may be ordinary year. So based on that, 0 bar 1 is given.
Okay.
So now I have to take the empty page and few concepts I have to explain and come back to this. So I stop this one and share. Can you see the screen? White screen?
White screen.
Yes. So here we have leap year and just ordinary year. So in the ordinary year, we have 365. So we have 52 weeks and 1 day left. So this 1 day, we call it as odd day. And in the leap year, 366, we have same 52 weeks and 2 days left. These 2 days, we call it as odd days. So we have to calculate for the leap year. So this actually, we have to calculate for 100. See, centenary years, we have to take it. So what is the meaning of centenary years? Centenary years, which means 100, 200, 300, 400, etc. So do you think 100 is a leap year? Centenary years, I have taken the centenary years. Do you think 100 is a leap year? So usually how we teach leap year means a number divisible by 4. We say it is a leap year. So now I just ask you the question, 100, 200, 300, 400, are they all leap years? And first question is 100, is it a leap year? Yes or no? Just you can give the answer yes or no alone. What about 200? What about 300? What about 400? Are they leap years? Okay, no idea. So actually it is not a leap year. So it is not a leap year. At the same time, 200, 300, all the three are actually, they are not leap year. But 400, we say that it is actually, it is a leap year. So leap year concept is when you take the centenary years, when the number, the centenary years, when they are divisible by 400, we say that it is leap year. So why this question? So this also students may ask this question, why 100, 200, 300 are not a leap year? So this one, if you see the answer, it is, can you see the PowerPoint presentation? Can you see?
No, ma'am.
No, I'll stop once again. So you can see that why 100 is not a leap year. So these many reasons are there, many reasons they are giving. In that one reason is year 365, 24 days long, and every 4 years we add an extra day. And this extra day actually we overcorrect by about 0.01. Every 4 years we are additionally getting 1 day. That 1 day only we are adding in the leap year. So 4th year we are saying that it is a leap year. So 29 days in the February month. So in this way, when we calculate, so one complete century, when it is completed, what happens? Every 100 years, you may be adding some extra, some hours we are adding. So that will be compensated in the 100th leap year. In the 100th leap year, that will be compensated, and that will be denoted as it's not a leap year. So every 4 years we are adding. Along with that, not only it is a one complete day, along with that some more hours we are actually adding. So that 100 years, every 100 years, we have added some additional hours that together we consider as 1 day that will be removed from the leap year. And so the 100, 200, 300 is not considered as a leap years. And it is current year. So you can see that leap year is divisible by 400 only, we'll be considering as a leap year. So this concept, definitely the students will ask the doubt in this. So we have to explain now. So divisible by 400 only, we say that it is an leap year. So we can understand 400, 800, 1600 and 2000 in these years, etc. They are divisible by 400, and so they are leap years. Divisible by 400, and so they are, we can say that they are leaving the remainder 0. So here we consider that number of odd days 0. Number of odd days in all these cases 0. So again, I say this 100, 200, 300 are not actually leap years. They are those centenary, they are divisible by 4. They are not considered as a leap years, but 400. So numbers which are in the centenary years calculation alone, when they are divisible by 400, we say it is a leap year. So the number of odd days in all those years, 400, 800, 1600, 2000, we call the number of odd days are 0 here. So next in 100, so in 1 century, I take in the 100 years, how many odd days are there? So based on this only, the calculation fully we can work. So in 100, how many odd days? So how to calculate this? I divide 100. And we want to know in 100, how many leap years and how many ordinary years are there. So what I do, I divide this 100, everybody knows that it is 25. So 25, the number of leap years is 25, but since 100 is not a leap year, so I have to subtract 1 here. So 100 is not a leap year. So 25 minus 1, which is 24. So you have 24 leap years. And remaining in the 100, 24 leap years means remaining 76. 76 will be the non-leap year or ordinary year. Okay. So in the leap year, already we saw 2 odd days will be there. In every leap year, 2 odd days. So leap year, 1 leap year, you have 2 odd days. Then 24 leap years, how many odd days? 24 into 2, so you have 48. And 76 non-leap years. So 76 non-leap year, we know you have one non-leap year, 1 day, 1 odd day. So 76 non-leap year, you have 76 into 1, which is 76 year. So 48 plus 76, it is 124 odd days. These are all important to derive the answer. So I repeat, we are calculating. So once if you learned this concept, calculation is very simple. So first point, you should know that in 100 years, how many odd days are there? So in 100 years, how many odd days, how we are calculating? We are divisible by 4, we are taking how many leap years we are calculating. Since 100 is not a leap year, there are 24 leap years and 76 non-leap year. In the 24 leap years, every leap year 2 odd days. So 24 leap years, you have 48 odd days. Similarly, non-leap year, every leap non-leap year 1 odd day. So 76. So 124. See, again, it is so many 124 odd days. It is. So odd days is actually we have to calculate, divide by 7. So 124, when you divide by 7, what is left out? That only extra day only we call it as the complete week we should remove and see extra how many days are left. That is called as the odd day. So 7 we have to divide. You can see that 17 times you get remainder. It is 7. So again it is 54, 49 and 5. So you can see here, divide by 7, you get the remainder 5. So 5 odd days are there. So we can come to the conclusion that every 100 years, there are 5 odd days are left. So we have to calculate, suppose for 100 years, there are 5 odd days, then 200 years, how many odd days will be there? In 200 years, 5 plus 5. So it is 10. So when it is more than 7, you have to divide by 7. So always the odd days will be nothing. One complete week comes means you have to subtract the complete week and see that whatever the days left out. So you have here 3. So in the 200 years, how many odd days will be there? 3 here. And 300 years means you have to take 15. So 15 odd days divided by 7. So it is 2 complete week plus 1 day remaining. So in 300 years, 1 odd day is there. So this calculation only we are going to use it. So I repeat, first point is 100 years, number of odd days is 5. And 200 years, number of odd days is 3. And 300 years, the number of odd days is 1. And 400 years, the number of odd days 0. So next it is going on like a 400, 800, number of odd days 0. So all divisible by 400 fully, odd days 0. So this concept, if we know, we can do the sum. So I will do the sum now, how we are calculating. See the question. So this is what it's given here in the calendar. You can see that a century 100, number of odd days 5. In 200, the number of odd days 3 here. And 300, number of odd days 1. 400 means 0. So once again, it repeats. You can add 5 for every 100 and calculate. So now we come back to this question. And before that, I should assign one important thing, coding. So coding and decoding, you know that here we are going to code the word. And what is the code is? Can you see the screen?
No, madam.
No. Can you see the screen, sir?
Yes, yes.
Okay. So this is 100, it is 5. And 200, 3 odd days. 300, 1 odd day. 400, 0 odd day. And again, 500 means 5 times 5 you should take it, and number of odd days you can calculate. And here, this is the coding, decoding. So we have to decode finally. Now coding, we are going to code it. Sunday means 0, Monday means 1, and 2 for Tuesday, and 3 for Wednesday, 4 for Thursday, 5 for Friday, 6 for Saturday. So we'll start with Sunday 0. So using this, we are going to calculate that the 0, 1, 2, 3 and all, what are they? They are the odd days. So odd days, if you get the answer, final answer, 0 odd day means your answer is Sunday. 1 odd day means the answer is Monday. 2 answer comes means 2 odd days you are getting the answer, then Tuesday. So this is the finally we are going to apply. So now we'll calculate this question. So we want 29th November 1972. What was the day? I will work it for you now. This calculation. Can you see the screen? Sir, can you see the screen?
Yes, ma'am. Yes, ma'am.
So the question is, we want to find out 29th November 1972. So in this 1972, we have to see that nearest centenary year. Which is the nearest centenary year? Can you anyone say that? Which is the nearest centenary year? Completed one. You can see that
19.
19, okay, 19, but I want it exactly divisible by 400. So start with a 0 odd day so that that calculation will be easier. So
2000.
which year? Yes,
2000, madam.
2000, I want it completed years, sir. 1972 means
Four.
before years.
Okay.
Yes.
1000.
Somebody,
100.
which number, ma'am? 100.
1600.
Very good. 1600 years. This is the nearest centenary year. So in 1600 years, we have to start with 0 odd day. So I'm going to split this year 1972 in the part. So first 1600 plus 300. So here you are getting 1900. So 1900 we can get it. And along with that 72 is not completed. Till 71 only it is completed year. So we should calculate total number of odd days for the completed year only. So completed year 1971 only. So I have taken 1900. So along with that 71 plus the 1 year, separate 1 year, that is 1972. In 1972, it's not completed. In 1972, we need only up to 29th November only we need it. So up to 1971, how many odd days first we are calculating? We know that in 1600, the number of odd days is 0. And 300, can anyone say what is the odd day? We calculated already. How many?
One.
Odd day?
One, madam.
Yes, 1. Very good. And in 1971, in 71, we should calculate now. So in 71 years, how many odd days are there? So for this, we should know once again the same way, how many leap years, how many non-leap years. So 71, I divide by 4. And so we get 1, it is,
So,
so it is 7 times 28. So we get 3. Yes. So we need only how many leap years? There are 17 leap years, which means 54 we have non-leap years. So 17 leap years and 54 non-leap years we have. So these 17 leap years, every time we have 2 odd days. So 17 into 2 plus 54 into 1. For leap year, 1 odd day. For the non-leap, for leap year, 2 odd days, non-leap year, 1 odd day. So this total we get, it is 88. So 88 odd days comes in the 71 year, up to 71 years. That is 1600 to 71. We have 88 odd days. So it is more than 7 means we have to divide by 7. So 88 divided by 7, we get here. How many odd days here? Left out here it is. Can
4.
anyone say how many odd days? 4 odd days. Yes. So we have 4 odd days. So till 1971, we have calculated that 5 odd days are there. So 5 odd days. But still that 1972, we need to calculate till the month of November. So every month we have to calculate. I have taken one of the toughest question, actually, they will say the students, but actually direct questions, many are there. If everybody knows to do this one, they can definitely answer all other concepts also. That is why I have taken this. So now for the 72nd year, in 1972, we have to calculate the month. So first January month, we have 31 days. And February month, we have to take 29 days. What is the reason? It is a leap year. 1972 is divisible by 4. So it is a leap year. Leap year means we have to consider 29. So here the students make mistake. They will calculate everything correctly, but in this particular year, whether it is a leap year or not, they don't see. So full answer may go wrong. So we have to tell them clearly that it is a leap year. So 29. Next it is March. So March we have 31 days. And April again 30 days. And May 31, June it is 30, and July 31, and next August 31, September 30, October 31, and November it's not complete. See, November we need it up to 29 only. The question is up to 29th November. So November month is not completed. So November month fully we should not take, up to 29 days only. So the total number of days, if you calculate, already I have added, so 334 days comes. 334 days. So these many days totally available. So we have to divide this by 7. So how many complete weeks are there? We have to
34.
So how much, sir? Oh, sorry, 334. How many odd days can anyone say? Calculate this. 334. How many odd days?
5.
5 odd days. Okay. So 5 odd days, we have to take it along with this. So already we have calculated and added, and here you have up to 5 odd days. So I write all the calculation together. Till 1600 years, we have 0 odd day, and the next 300 years, number of odd days. So here it is 1, and 71 year up to 1971, it is 5 odd days. So we have totally
4, madam.
one more, 4 or
71
71 years,
years.
4 only here. Okay, 4 odd days. And in 29th November 1972, here 5.
Right.
So totally you get a 10. So in this 10 again more than 7. More than 7, you have to divide by 7. And so divide and see that 1 and the remainder is 1.
3.
Remainder alone we have to see. 1 plus the remainder is 3. So we can say that finally the number of odd days here, the number of odd days is 3. So 3 is assigned for which day? 3
Wednesday.
is assigned
Wednesday.
Tuesday, ma'am. Tuesday.
Tuesday or Wednesdays. 0
Wednesday.
is Sunday, 1
Tuesday,
is
ma'am.
Monday, 2 is Tuesday, and 3 is Wednesday.
Wednesday.
So what is the answer? Wednesday is the answer. So 29th November 1972 was Wednesday. Can you all understand? Can you get it?
Yeah.
Yes, yes.
So we'll work one more question then. Shall we do one more question?
Yes, ma'am.
You can work it and you can tell me. You can calculate and tell me the answer. So I just show the screen. So there are different types of questions. There are many questions. See, it is same concept. There are different questions. Can you see the screen, please? Can you tell me?
Yes, ma'am.
So question is find the odd day on 3/3/2001 and find the day on 15/8/1947. So our Independence Day, you can calculate what is our what was the day. Can anybody knows already? Somebody you know, you can tell me that. What was the day? 15th August 1947. We have to calculate. So shall we work this question? 15th August 1947.
Yes, ma'am.
So can we all join together and work? So with that we can conclude. Find the day on 15 08/1947. So starting with so which year we can start here?
1600, ma'am, plus 300 plus 47.
Yes, sir. Good. So in 1600 years, 0 odd day. So will you take 47 or 46 years here?
46 years.
46 years. Yes, good. So only 46 years we have to take. In this 46 years, we have to identify how many leap year, how many non-leap years. So how many leap years are there in the 46
11.
years? 11, yes. So 11 leap years
35 non-leap years.
and 35 non-leap years. So the 11 into 2, the calculation is 11 into 2 plus 35 into 1. So 22 plus 35, 57 days totally comes, odd days. And this we have to divide by 7. So 57 divided by 7. So how many odd days here we found? Anyone calculated?
1 minute.
1 odd day. Yes, sir. Good. Correct. 1 odd day. So for 1947, we have to calculate up to August. So 15th August 1947 calculation. January month 31 days. February month 28 days. March 31. April 30. May 31. June 30. July 31. And August is only up to 15.
Yes.
So what is the total?
227.
227 is
227.
227 divided by 7. So here number of odd days?
3.
3, sir.
3, madam.
Okay.
3.
3 odd days. So
Yes.
total number of odd days now we have to
4.
calculate. Number of odd days.
4, 5.
What day, sir? Anyone found?
For Friday, madam.
Friday, yes, sir. Correct.
Answer is Friday, ma'am.
Yes, sir. Correct. Good. Friday. Thousand 600 years, 0. In the next 300 years, it is 1. And for 46 years, 1 odd day. And for the year 15th August 1947, we get how many odd days? 3. So totally it comes 5. So number 5 we are decoding. So it is 5 is assigned for Friday. So
Friday.
Yes, Friday is the answer. So there are some more questions like Monday fell on which dates? of June 2003. Same concept only. We have to calculate Monday. We have to calculate in the June month how many Mondays. And here say next level. 15th February 2010 was Monday. Then what was the day on 10th January 2006? So based on this, if it is Monday, what will be the day on 10th January? The same calculation only, little bit small changes we have to make it here. So Monday fell on which dates means what we have to do here is a very simple question only here. We have to find the calculation same manner, like 0 odd day starting with 2000. So nearest centenary year is 2000 is there. So 2000 up to 2002 and June month we want it. So we have to calculate June 1st is what day. So June 1st, what day we have to calculate? 1st June, if you know, based on that, we want Monday. So 1st June, for an example, for this year 2003, 1st June will be Sunday. So we want Monday of the year, month means Monday will be second. So second will be Monday. So all calculation 2, 9, 16, 23, all the dates of the month will be Mondays. So the calculation will be based on this odd days only, everything. So any doubts in this, I'll stop it. So today's session, I've completed what I planned.